Okay, now we're going to be talking about statistics. And statistics are what allow us to analyze data and be able to interpret it, to be able to then draw conclusions from the data, allowing us to essentially gain knowledge in psychology. So statistics are a very important and powerful tool that is necessary to the psychologists have a basic understanding of this. So let's talk about some of the basics. There are two basic categories of statistics. There are descriptive statistics and there are inferential statistics. Descriptive and inferential statistics tell us two different things. Descriptive statistics, as the word suggests, describe or summarize data. So some examples of descriptive statistics include the mean, the median, the mode, the standard deviation. They tell us something about the set of scores. They just describe what the set of scores essentially looks like. Inferential statistics, on the other hand, allow us to draw conclusions about it. And typically what we do in psychology is we draw a sample from a population. We study the sample. We gather scores from the people in our sample. And from the scores that we get from the people in our sample, well, the scores that we get in our sample, we would be using descriptive statistics to measure what we see in our sample. But we would then use inferential statistics to be able to draw conclusions. Well, through the results that we get in our sample, can we generalize from that to the population? Inferential statistics allow us, by using probability, to draw conclusions from the sample to the population. So let's start with talking about descriptive statistics. One category of descriptive statistics are measures of central tendency. Okay? So let's say we've got a set of scores here. Okay? You have 3 people who scored 0, 1 person who scored 10, 1 person who scored 13, and 2 people who scored 20. We want to find out some information about these sets of scores. Well, one thing that we could find would be the mean, or the average. With the mean, what you would do is you would count the number of scores. In this case, we have 7. So the letter N refers to the total, the sample size. So we have a sample of 7 scores here. The N is 7. We then add up all of the scores, so the sum of the scores is equal to 63. We take the sum of the scores divided by the number of scores, and that's how we compute the mean. 63 divided by 7, so the mean is 9. What the mean tells you, the mean is like the balance point in a distribution. It takes into account all the high scores, all the low scores, all the scores around the middle, and the mean tells you the exact balance point, balancing off the high scores from the low scores. So, for example, let's say I added another score at the end here, a score of 100. Well, what would happen to the mean? The mean would no longer be 9, it would be quite a bit higher than 9. What if we added a score down here of negative 402? Well, that mean of 9 would be certainly changed to be a lot lower based on that one score. And those scores that are kind of like way high or way low, those are actually called outliers. And what happens with the mean is that an outlying score, an outlier, can really play games with the mean. If you have a really high outlier, well, the mean may be higher than you would expect based on that one score that's way, way, way higher than everybody else's. It's sort of like a circumstance where, maybe everybody in the class does really badly on an exam, but then there's one student or 2 students who do really, really well. So like maybe you've got like 20 students, maybe like 18 students got like a 20 or less, but then one student got 100. Well, the mean would be higher, be based on that one score, be high, but really, just ignoring that outlier, you had a score where pretty much everybody did badly. So the mean can change a lot based on outliers. Next we have the median. And the median is the middle score. It's the score at the midpoint. If you take a look here, the score of 10 is the median. Half the scores are higher, half the scores are low. We got three people who scored 0, and one person who scored 13, two who scored 23, 3 above the median, 3 below the median. The median is the middle score. If there were an even number of scores, then you would take the 2 scores that are in the middle and average them. Okay. So, but now take a look here. What if instead of the score of 20, the score was 2,000? What would the median be? Well, the median would still be 10. What if instead of 0, the score was negative 524? What would the median be? The median would still be 10. Well, what does that tell you about the median as compared to the mean? Well, what it tells you, it should tell you, is that the median is unaffected by outliers. It doesn't matter how high scores are on one end, it doesn't matter how low scores are on the other end, the median is the midpoint. And that's actually some useful information, because if you go back to like that class where everybody did poorly except for one smart guy at the top, well, the median would be damn low in that case, wouldn't it? The median would be low score, because the median would not be affected by that score that's way up high. So the median tells you something. So in other words, if you've got a mean that maybe in that case the mean would be like 60, but the median would be like 30. Well, that tells you, whoa, maybe there's an outlier there, because the median is unaffected by outliers. The mode tells you something different. The mode tells you the most frequently occurring score. And in this case, 0 is the mode, because there were 3 scores of 0, and no other score occurred more often. So the 3 is the most frequently occurring score. Now, why is the mode important? It tells you, if you're talking about probability, it says what is the score that you're most likely going to see in this distribution? Well, the most frequent score is 0. Let's say instead of 3, instead of 3 people scoring 0, what if we said 47 people scored 0, and leaving the rest of the scores the same? Now, if you put all of those scores into a fishbowl and reached your hand in and grabbed a score, well, which score do you think you're most likely to get? Clearly, you're going to most likely get a score of 0 when you pull it from the hat. So knowing the most frequently occurring score kind of tells you something about the distribution. What's the score that appears the most frequently? That's what you'd like to, that's important information. An example of where the mode might be important would be in the game of blackjack. The purpose of the game of blackjack is to beat the dealer, to beat the dealer's hand. You don't know what the dealer has. The dealer shows 1 card up, 1 card down. You get 2 cards yourself, so you know what you have, but you don't know exactly what the dealer has. With blackjack, the value of the cards is important. You have cards valued 2, 3, 4, 5, 6, 7, 8, 9. The value of that card is the number on the card. So a 7 has a value of 7. An ace can have a value of either 1 or 11, depending on how it makes your hand. 10s, jacks, queens, and kings, however, all of those cards have the same value, 10. The object of the game is to get as close to 21 as possible without going over, and to have a score that beats the dealer. So, with the game of blackjack, your strategy is based on the assumption that the most frequently occurring card is going to be a 10. Therefore, if you want to guess as to what the dealer has hidden underneath his card, you have to make the best guess to be a 10. Because in a deck of cards, there are, let's say for the 7 card, how many 7s are there in a deck of cards? 4. How many aces? 4. How many 3s? 4. How many 8s? 4. Okay? 4 of those cards in a deck of cards. Now, how many cards in a deck of cards based on the rules of blackjack have a value of 10? Well, in this case, you have 16 of them, because there are 4 10s, 4 jacks, 4 queens, and 4 kings. 16 cards that have a value of 10, which means that in a deck of cards based on the rules of blackjack, the mode is a 10, which means that you have to assume that the dealer has a 10 underneath. You have to assume that if you draw a card, it's probably going to be a 10 based on probability, based on the most frequently occurring card in the deck. So if you assume that the card is probably going to be a 10, that's how you make your decisions. That's what strategy is based on. Okay? So knowing that so this is an example where the mode is actually important. It gives you some important information about what is the likelihood of what the next card will be. In this distribution here, what is the most frequently occurring score? It's 0. What's the most likely score you're going to get if you draw it from a hat? 0. Okay? And so that, again, gives you important information. All of these are descriptive statistics. They tell us something about the distribution. Now, something else that we need to learn about the distribution involves measures of dispersion or measures of variability. Measures of dispersion tell us how much the scores are spread apart. One measure of dispersion is called the range. The range is simply computed as the highest score minus the lowest score. So in this case, the highest score is 20, the lowest score is 0, so the range is 20. Now, if you look, that means that these scores are kind of spread apart a lot, right? Let's say this is an exam, or let's say that this was an assignment in which the highest score is, in which the maximum score is 20 and the lowest score is 0. Well, you got 3 people who scored a 0. Maybe they didn't do the assignment, right? 2 people scored 20. They got a perfect score, and 2 people scored like kind of half, like not really that good. So basically, if you take a look at it here, really, you've got 5 out of 7 students who really didn't do that great on this assignment. So that tells you something, that maybe the assignment isn't, maybe is not right. But you'll also have 2 people who did really well. So it may be telling you that you've got some variety in the students in your class, because you've got some students who do really well, some students who do really poorly, okay? And others who do kind of in the middle. Now, by the way, I expect this to happen anytime I give an exam in a psychology class. If I give an exam in my psychology class, I don't have a circumstance where everybody fails. I don't have a circumstance where everybody gets an A. I have scores kind of like all over the place. I have some students who do really poorly. I have some students who do really well. And I have a lot of scores kind of in the middle. And that's kind of the way it usually is. And it kind of looks like what we call a bell curve, but we could talk about that later. But this this tells us something about the, it tells us something about the distribution. Now, what would happen if, for example, remember here, in this particular case, the mean here was 9. Okay? What happens instead of having the scores spread the way they are right now? What if instead of that you had 3 people who scored 8? Okay? 3 people who scored 10, and 1 person who scored 9. In that case, the average would still be 9. However, the scores would be much closer together. Obviously, the range would be smaller because it would be 10 minus 8 would only be 2. But in this case here, you can see that the scores are most closer together. People are scoring about the same way. It kind of tells you that maybe if we're talking about an assignment, maybe everyone in the class has a similar ability on this particular assignment. So that is an example of why that's important, why measures of dispersion are important. It's important to see how spread apart the scores are. Another very important measure of dispersion is called standard deviation. And the standard deviation is essentially the average deviation from the mean. It's the square root of the average square deviation from the mean, essentially. So in other words, you are squaring the deviations from, how scores deviate from the mean. Some scores are higher than the mean, some scores are lower than the mean. You square those deviations, and then you take the square root of those. Essentially, that is the standard deviation. So mathematical formula for it, you don't need to know the formula. You don't need to be able to compute the standard deviation, because you need to basically understand what it is. Average deviation from mean. How much do scores on average deviate from the mean? In this case, the mean is 9. So like 20 deviates from it quite a bit. 0 deviates from it quite a bit. 10 and 13, not so much, So you can kind of see which scores are closer to the mean, which scores are further away from the mean. You can actually use the standard deviation to compute something called standard scores. Standard scores are very important information when it comes to kind of identifying where scores are in the distribution. So what I could do is I could compute each of these scores and translate them into standard scores. When you compute a standard score, what you're doing is you're using the standard deviation to create a new value, which essentially says where your score is relative to the mean. So, for example, if I convert a score into a standard score, if the score is positive, it indicates that the score is higher than the mean. So, for example, 10 is higher than the mean, 13 is higher than the mean, and 20 is higher than the mean. If we get a standard score that's negative, then we know that the score is lower than the mean. So the score of 0 is less than 9, so it's lower than the mean. So when you convert a score into a standard score, you're getting it's either going to be positive or negative, or it's going to be 0. What do you think a standard score of 0 means? A standard score of 0 means that you scored exactly the mean. So in this case, if you got a 9, if you had someone who scored 9 here, the 9 would be the mean. And the standard score would be 0. That means that that person scored right there on the mean. So positive tells you higher than the mean, negative means lower than the mean. But the value of the standard score tells you how far apart it is. So for example, if you have someone who has a standard score of positive 1.5, that means that person scored 1.5 standard deviations above the mean. If you had someone who scored a -2, a standard score of -2, that means it's 2 standard deviations below the mean. So if you take a look here, the standard deviation is 9.147. So for example, remember the mean is 9, right? So if someone who scored about 18, then a score of 18 is about 2 standard deviations above the mean. So because if the standard deviation is 9, if the mean is 9, excuse me, no, it will be, a score of 18 would be 1 standard deviation above the mean. The mean is 9. So a score of 18 would be 9 plus 9, which is 18, so it would be about 1 standard deviation above the mean. And a score of 0 is about 1 standard deviation below the mean. 9 minus 9 is 0. So again, it gives you an indication of where your score is relative to all the other scores in the distribution, relative to the mean. When I give a psychology exam, I could convert scores into standard scores. So if you did really well, you might get a positive 1.5 as your standard score. If you did really poorly, maybe like a negative 1.3 or something like that. Well, we talked about descriptive statistics. Now let's talk a little bit about inferential statistics that allow us to draw conclusions. The most important thing about inferential statistics, it's a good way of putting it, it's a bridge between the sample and the population. It allows you to draw conclusions. Here's what I got in my sample. Let's see if we can make this conclusion in the population. If you're testing to see whether or not a drug works, and maybe you do a placebo-controlled double-blind study to see whether this migraine medicine actually works for migraine sufferers. One group gets the migraine, one group gets the pill, one group gets a placebo, and you see that the people who got the migraine drug, they feel better. The drug worked better for them than the group that got the placebo. So their headache go away faster. So maybe it works in your sample. Maybe you find in your sample that the people who took the migraine medicine, their headaches went away faster than the group that got the placebo. So that's all well and good, but we want to be able to see whether or not this might be true in the population. The answer is we don't really know if it's true in the population. We know it's true in our sample, but we don't know if it's true in the population. So what we want to be able to do is we will say use probability to make the determination. Well, the drug really worked in our sample, and maybe if we got like a large enough sample size, and if we did the study properly, then maybe we can conclude that, you know what? Maybe we can conclude that the results we got in our sample can be generalized to the population, and that's where you would be using inferential statistics. So you're making a hypothesis essentially that the migraine medicine works better than the placebo in treating headaches. It's a reasonable hypothesis. But your hypothesis essentially is based on what you'd hope to see in the population. You don't really care about the 120 or 30 or people in your sample. You want to be able to say, make the conclusion that the drug would work in the population. And that's what inferential statistics will tell you. The concept of statistical significance is relevant here. We essentially are making a decision based on probability. So let's say the drug worked in our sample. The people who took the migraine medicine, their headaches went away in 30 minutes. The people who got the placebo, maybe on average, headaches went away in an hour and a half. Okay, so the headaches went away faster in the group that got the drug. We know that is true in our sample, but can we conclude in the population? Well, what is the likelihood of this result happening just due to chance? Is it possible that the people who got the migraine medicine, they just happen to heal faster than the people who, the migraine sufferers in the other group? It's possible. But if you did random assignment to conditions so that the two groups are no different before you begin, well then, you know, it's probably not that one group is, you know, just as fast healers than the other, you know. It's a random assignment, it's higher than likely that that's going to happen. Statistical significance is based on the decision that if the result you got, if it's only due to chance, what is the likelihood that it's only due to chance? If it's only 5%, or if it's 5% or less, that the results you got are just due to chance, just due to dumb luck, then you're going to conclude that the results you got are not due to chance, that you would reject that idea, and you would say, in fact, the drug works. And you're saying that there's a less than 5% chance that the result I got was just due to chance. Therefore, I am going to conclude that the results I got are statistically significant and that the drug works significantly better than the placebo. And that's the decision you make using inferential statistics. And if the results are statistically significant, then you would make the conclusion that not only does it work in my sample, but we're going to make the conclusion that it also works in the population, and we're going to be ready to manufacture this drug and put it on the market. Because the results that we got are, much more, is much more likely that the results we got are due to the drug working than just due to chance. And that's what statistical significance is all about. See, that alpha, that confidence level of 0.05, you might have even seen it if you read a journal article. You might have seen P is less than 0.05. P stands for probability. The probability of getting the result you got is less than 0.05, or meaning less than a 5% chance that the results you got are just due to chance. So that 0.05 level is the standard that scientists, not just in psychology, but in many other scientists, use. So that if the probability of the results you got are 5% or less due to chance, then you are going to make the conclusion that the results you got are statistically significant. You're going to make the conclusion that the results are true in your sample and also true in the population. That the drug works in my sample, well, I'm going to conclude that it also works in the population because my findings were statistically significant. And that's what I'm talking about. That's where inferential statistics. You can see how inferential statistics tell you something deeper than what the descriptive statistics does. Descriptive statistics just describe, but inferential statistics really kind of point you in the direction that the results from your sample to the population. And there are many different inferential statistics tests based on the type of design you're using. So there could be a t-test, an analysis of variance, correlation, number of different statistical tests that you can apply that you could then use as an inferential statistic to draw that conclusion. Now, it's important when you are describing data, when you are essentially communicating your findings to other people, you want to be able to do it in a way that is not misleading, that is honest. And I want to point out that there's actually a very famous saying, I don't know whether it was Mark Twain or whoever said it, but there are lies, there are damn lies, and there are statistics. And what that means is that you can use statistics in a way that can be very misleading. So it sounds like you got something important to say, but really you're making a lot more of it than it actually is. Here is an example, and this is an adaptation from an actual automobile ad. If you look at this chart over here, and this chart essentially is talking about the reliability of a particular truck. If you look at our brand over here, and you can see this reliability is a lot higher than the reliability of all these other competitors. Percent still functioning after 10 years. Boy, I want to keep my car a long time. I'm going to choose this brand here rather more than these other brands that are so unreliable, right? Well, take a look over here. Look at where this chart graph is beginning. It's beginning at 95% still functioning. Do you know what that means? All of these brands are pretty damn reliable. All of them have a large majority of them still functioning after 10 years. Well, the second chart tells you the same, gives you the same information but in a less misleading way. It's starting at 0. And then you can see that your brand of truck, while it is higher than the others, it's not so impressive anymore. So realize that you can describe data, you can display data in a way that is misleading. Let's go back to the example with understanding the mean, the median, and the mode. I'm going to explain why it's important for you. Even though you're not necessarily going to be scientists, you're not necessarily going to be psychologists, why it's important for you to understand why understanding what the basics of that is important. If someone tells you that you can work for a company when you graduate from college that has a mean salary, an average salary of $150,000 a year. Now that sounds like a pretty good salary. And I would jump at the chance to work at a company where the average salary is $150,000 a year. But you might want to get a little bit more information. One piece of information that might be helpful is, well, we know what the mean salary is, but what is the modal salary? What is the mode here? What is the most frequently occurring salary at this company? Well, maybe at this particular company, most of the people make minimum wage. How could it be that most people make minimum wage, but the average salary would be so high? Well, maybe you've got a bunch of people who make the minimum wage, but a few people up on top that make millions. And in that case, you're going to have a very high average salary, but the mode is going to tell you something different. Maybe in the world, maybe you start working for something where what is the most likely salary you're going to get? Well, you're probably going to get minimum wage if that's the case. You don't want that. You might also ask, what is the median salary? The midpoint tells you the middle of the distribution, the halfway point, how many people scored higher, how many people scored lower. The middle score, the middle salary in that company will tell you, you divide all the employees, and half the employees make higher than this, half the employees make lower than this. Well, if the median salary at this company is only $20,000, that tells you that half of the company makes less than $20,000 a year. Half! You would then run screaming away from that company. Even if the mean is high, because remember what we said about the mean. The mean is highly affected by outliers. Score is way up high, score is way down low. It can really affect the mean. And if you've got a company where a whole bunch of people make really low salaries, but a few people at the top make really, really high salaries, then you're going to have a mean that's going to be distorted. That mean is going to be higher than really what you would expect your salary to be if you worked there. That's an example of how you may be giving the mean correctly, but it's deceptive if you don't know any further information. That's why it's important to have a basic understanding of statistics.